Alright, welcome back to Apologia Chemistry, Module 11. We're on page 374. We were talking about freezing point depression, and we're going to just be continuing on with a very similar concept. Boiling point elevation. Boiling point elevation, we're on page 374. And the boiling point elevation is very similar to the freezing point depression. When a solute is dissolved in a solvent, the boiling point of the resulting solution is higher than that of the pure solvent. And the formula for that is 11.3 on page 374. It says the change in temperature, delta meaning change, is the number of ions. We said that's how an ionic compound breaks up, times that Kb, which is the boiling point constant that will usually be given to you, multiplied by the molality. And we said molality is another word for concentration. In this case, the concentration is the moles of solute by kilogram of solvent. So if you look at page 374, there's a couple of examples on 374 and 375 that show how that works. And I would like to go over one more example for you. That would be on your own, 11.10, which is at the bottom of page 375. We're going to walk through that. And the problem says if you wanted to boil a solution made by dissolving 250 grams of table sugar, C12H22O11, into 1.3 kilograms of water, to what temperature would you have to raise it, where the Kb of water is 0.512 degrees C per mole? So the first step, we ask, what equation do we need? Okay, and we know we need that boiling point equation because that's what it's asking about. And that is delta T equals the number of ions times the boiling point constant times the molality. So let's look at what you're given. You're given the number of ions, because in this case it's C12H22O11. Okay guys, is that ionic or covalent? You're right. It's not ionic because there's no metal. Okay, it has to be covalent. Now if it's covalent, you're only going to have one ion. That I will be 1. Okay, since it's not ionic, the I is 1 because it doesn't break down into any ions because it's covalent because there's no metal. So the I there is going to be only 1. Okay, and what is Kb? Well, we're given that. It's 0.512 degrees C per mole, per molal. And then the only thing we don't know is the molality, which is going to be the moles of the solute divided by the kilograms of the solvent. Well, we're given a number of grams of the solute, and we're given the number of kilograms of the solvent. So what are we going to have to do? We're going to have to find that molality, little m, the moles of solute divided by kilograms of solvent. So to find the moles of solute, we take the grams, we convert it. We know the gram formula weight by finding that in the chart is 342.2 grams per mole. And we plug all that in and we find that the number of moles is 0.73 moles. And then we can plug that into our molality equation where it says moles of solute divided by kilograms of solvent, 0.73 moles of C12H22O11 divided by 1.3 kilograms of the solvent, which in this case is water. Okay, and 1.3 kilograms. We get 0.56 is our molality. Now we plug all that into our delta T, 11.3, and we find that 1, that's the number of ions, I, times 0.512, which is the Kb, which is given to you, times 0.56, which is the molality that we found by dividing the moles by the kilograms. And the answer to that is 0.29 degrees C when we multiply that out. Now, but that isn't what the question asks. The question says, to what temperature would you have to raise it? So we know that water boils at 100 degrees C. That's something we're supposed to memorize. And if we add that change in temperature, delta T is a change in temperature, we add that change of 0.29 degrees C and round it, we find that the actual temperature is 100.3 degrees C. So again, that's pretty much all for the chapter, except I want you to really understand this ions. So again, how do we find that I? How do we find the number of ions? Well, keep in mind, the first question you're going to ask, is it ionic or covalent? If it's not ionic, then there's only going to be one ion if it's covalent. If there's no metal, there's only going to be a 1 there, okay? If it's ionic, you have to say, how many ions does it break down into? So let's look at some examples of that. Let's say you have NaNO3. Well, remember, NO3 is one of those polyatomics that you were supposed to memorize from page 288. So NO3 is only 1 ion. It's not separated because this is a polyatomic ion. It's only 1 ion. NO3 is one and Na is another one, so you have a total of 2 ions. Now here with magnesium nitrate, you have 2 NO3s. So it's going to be 2 ions plus 1 ion for a total of 3 ions. And here with aluminum that has plus 3, you have 3 ions plus 1 ion for a total of 4 ions. So you would plug in, if it was changed, you would plug in for the I these numbers. So the question might be, and this shows up in your review question number 10, then that's on page 381. The question might be, if you wanted to protect water from freezing, which compound would accomplish this the best? NaNO3, MgNO3 or AlNO3? And we said, of course, if the number of ions is greater, that's going to accomplish that best, to protect the water freezing. The more ions you have, the better it's protected from freezing. So the one with the most ions is going to protect it better from freezing. In this case, the most ions is here. So that would be the answer to that review question for Module 10. So again, guys, that's pretty much all there is to Module 11. I'm not going to spend a whole lot of time on this on Monday. I hope you watch these videos. And I want you to read Module 12. We'll be getting into Module 12 on Monday when you come back. Thank you for all the time that you're putting into this on your own time. Thank you. Goodbye.